Hi, I'm Bill Kinney, and this is video number 18 of my series on arithmetic, algebra, and graphing. This is video number 18 again. It's a part of a sub-series called the Arithmetic of Rational Numbers, also known as Fractions, Part 7. In the last video, we ended with an example, starting to think about an example about cutting up French silk pie. Into 12 equal pieces. On the box of the pie it said a serving was 540 calories and a serving was 1/8 of the pie, but I cut it into 12 pieces, smaller pieces. How many calories was in one of my 12 pieces? I drew two diagrams, each representing the same pie really. This one, if I cut it in 8 equal pieces, and if I did so, this one piece, this 1/8 of the pie, would be 540 calories. The piece I want to eat, I'm cutting into 12 equal pieces here. The one I want to eat is going to be an unknown number of calories. That's what I want to find. Question mark calories. It's going to be smaller than 540, and I also argued it was going to be bigger than 270. Because if I cut this in half, that would be 1/16 of this pie, which is smaller than 1/12. But it would not necessarily be halfway between 270 and 540 for the answer. Let's see if we can figure out what it'll be. Now I'm not going to add these numbers. I'm not going to add 1/8 and 1/12 here, but it's still going to be helpful for me to figure out the least common multiple, which I'll abbreviate in the standard abbreviation LCM. Stands for least common multiple of 8 and 12. Even though I'm not going to add 1/8 and 1/12, it's still handy to find that. And if you think about it, you should see that the answer is 24 here. Actually, you can figure that out with prime factorizations as well. 24 is the smallest number that is a multiple of both 8 and 12. It's 8 times 3 and 12 times 2. 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. And 24 is 2 times 2 times 2 times 3. So it turns out the least common multiple can be formed by taking each of the primes that occurs in these, it's a 2 and a 3, taking the greatest number of those primes and putting them together. This 8 has 3 2's in it, so take 3 2's over here. No 3's. 12 has 1 3 in it in its factorization, so take one of those, that 1 3, to form the least common multiple, which is 24. Why is that important here? It's going to help us figure out the answer to the question and also motivate what it means to divide fractions. So we're getting into fraction division here. Because 24 is a multiple of 8, I can take this pie that's cut into 8 equal pieces, and I can cut it into 24 equal pieces if I just take each one of these 8 pieces and cut it in thirds. Like this one there, and I'll continue. I won't bother doing the whole pie. I would continue around the pie, creating 24 equal pieces. Since 12 is a factor of 24, 24 is 12 times 2, I can also create 24 equal pieces over here, but now by dividing each of these smaller pieces in half. To create 2 equal pieces for each part, and then ultimately again 24 equal pieces total. Because of this, think about this, because of this, that means this pie, that's 1/12 that I want to eat, is made up of 2 of those smaller pieces that are 1/24 of the whole pie, whereas this pie, that's one piece, that's 1/8 of the whole pie, is made up of 3 of those smaller pieces that are each 1/24 of the pie. Therefore, this piece of pie is 2/3 as big as this piece of pie, because you got 2 of those pieces there, 2 real small pieces making up that piece, and 3 of the real small pieces here making up this bigger piece. What that means is the answer to this question is going to be 2/3 times 540. That'll be how many calories? See if you can do this in your head. We can do a little cancellation here. 3 does go into 540. If you think about it, hopefully you see it goes in 180 times. It goes into 600 200 times, and 540 is 60 smaller than 600. 3 goes into 60 20 times. It's got to be 200 minus 20 there. So we ultimately end up with 2 times 180, 360 calories. For my piece, that's 1/12 of the whole pie. And indeed, 360 is not halfway between 270 and 540. It's 90 above 270, but it's 180 below 540. So it's not halfway between. 1/12 is not halfway between 1/8 and 1/16, even though 12 itself is halfway between 8 and 16. A little weird. Think about what I just said there. Stop and think about it. What did I say here? 1/12 is not halfway between 1/8 and half of it, 1/16, even though 12 is halfway between 8 and 16. It doesn't work that way for fractions. In the time we have remaining here, I want you to also realize that this 2/3 can be found out as a fraction division. What I can do here is to figure out what fraction this piece of pie is compared to this one, is I can take what that slice is, 1/8, and I can divide it, 1/12, 1/12, and divide it by what this bigger piece of pie was, 1/8. And that division, we will see, is going to be 2/3. As far as the process of what you do, you may remember that you do what's called invert and multiply. You make the division symbol a multiplication. You invert the fraction over here. Instead of a 1/8, you make it an 8/1. This gives you 8/12, which is 2/3. So why do you invert and multiply? Well, you do see at least it gives you the right answer here. 2/3 was ultimately the thing that we multiplied by here. It is how big this piece is compared to this piece. So one justification is, well, it gave us the right answer. I suppose you could think of it another way. This is sort of a visual and answer-wise justification. You could justify it algebraically as well, because 1/12 divided by 1/8 could be thought of as a sort of a big fraction, where both the numerator and denominator themselves are fractions. That is okay to do. And do a little trick. Multiply this fraction by, in this case, 8/8. That's not going to change the value of the overall fraction, so to speak, because 8/8 is equivalent to 1. That's what this is here, 8/8. It has the benefit of having some cancellation happen. You do still multiply the numerators and denominators individually. Oops, 8 there. Just like you do when the numerators and denominators are both integers. And then we've got fractions in here as well. And again, I can think of 8 as 8/1. The 8's cancel there, and all the 1's can be done away with. I got really a 1 on the bottom, in the end giving me 8/12, 2/3. The same answer. So this is sort of an arithmetic or algebraic way of justifying why we ultimately do this calculation in the end. The 8's cancel on the bottom, leaving a 1 on the bottom, and we really end up doing 1/12 times 8/1 to get the answer. That's sort of an arithmetic or algebraic way of justifying it. Here we saw, I just did it, and we got the right answer. We got what we saw we should do visually. So that's a little bit about dividing fractions. That's our intro to it. In the next video, we'll delve into it a lot more.